Hello, everyone. In the field of precision measurement technology, establishing a coordinate system is a key step to ensure measurement accuracy and efficiency. Imagine, without a unified reference framework, how could we accurately evaluate the dimensions and positions of parts? Today, we will explore how to use the 3-2-1 method to establish the workpiece coordinate system, which is crucial for our measurement work. Next, we will study the following contents. Through this lesson, we hope you will be able to proficiently master the 3-2-1 method for establishing workpiece coordinate systems and use the workpiece coordinate system for precise measurements. Let's first understand the importance of establishing a coordinate system. During the measurement process, it is usually necessary to use the parts datum to establish a coordinate system to evaluate tolerances, conduct auxiliary measurements, specify part positions, etc. This coordinate system is called the workpiece coordinate system. When establishing the workpiece coordinate system, the first axis, second axis, and coordinate origin are determined based on the A, B, and C datum specified in the part drawing. The workpiece coordinate system is very flexible and convenient to use, and it can even be used to generate elements that cannot be measured directly. 1. Achieving mathematical alignment of the part, establishing the part datum, and accurately measuring one-dimensional and two-dimensional elements, as well as evaluating distances, positions, and other dimensions with specific directional requirements. 1. Establish the part coordinate system based on the part datum. Only by following the direction of the part coordinate system can we obtain correct distances, as shown in the diagram. 2. On the drawing, dimensions are generally marked starting from the datum. As shown in the diagram, after establishing the part coordinate system based on the datum, the coordinates of the measured features can be easily obtained. 2. The completed program can achieve batch automatic measurement of workpieces. 3. Through the fitting of the workpiece coordinate system and the CAD coordinate system, CAD can be used to assist in measurement. Next, let's look at the principles of the 3-2-1 method for establishing a coordinate system. In practical applications, based on the datum features of the part during design and machining, there are 3 methods to establish the workpiece coordinate system: the 3-2-1 method, the iterative fitting method, and the best fit method. The following introduces the 3-2-1 method for establishing a coordinate system. In a 3D rectangular coordinate system, any part has 6 degrees of freedom, which correspond to rotations around the x, y, and z axes, as well as translations along the x, y, and z axes, as shown in the diagram. By restricting these 6 degrees of freedom, a fixed coordinate system can be established, as shown in the diagram. Establishing the workpiece coordinate system is to constrain the 6 degrees of freedom of the part within the machine tool coordinate system. The basic principle of the 3-2-1 method for establishing the workpiece coordinate system is as follows. Measure 3 points to define a plane, and take its normal vector as the first axis. Measure 2 points to define a line, and use the direction of the line, from the starting point to the end point, as the second axis. Finally, measure 1 point to determine the coordinate origin based on the measured plane, line, and point. Let's continue to explore the steps for establishing a coordinate system using the 3-2-1 method. 1. Alignment. Align the first axis of the workpiece coordinate system. Use the vector direction of the first reference plane feature to determine the first axis direction of the coordinate system. As shown in the diagram, after measuring 3 points on the upper plane of the part, a plane is determined. The vector direction of the plane is aligned to the z-positive direction of the coordinate system. At this point, the rotational degrees of freedom of the part around the x and y axes are constrained. 2. Rotation. Rotate around the first axis to determine the second axis, and the third axis direction is also determined simultaneously. Use features on the second reference plane to define the second axis direction. As shown in the diagram, measure 2 points on the front plane of the part to determine a line. The vector direction of the line is rotated around the z-positive direction to the x-positive direction to determine the x-axis positive direction. This constrains the rotational degree of freedom around the z-axis. At the same time, the y-positive direction is naturally determined because the third axis is always perpendicular to the first and second axis. 3. Setting the origin. Use the datum to define the 3 origin points of the coordinate system. Translate the x, y, and z direction origin points to the measurement features of the 3 datums. As shown in the diagram, use the measured plane line point to determine the coordinate system origin. This constrains the translational degrees of freedom of the x, y, and z axes. Next, let's perform the actual operation of establishing the workpiece coordinate system. First, switch the probe to A90B 90. Then, use the joystick and the probe to collect 4 points on the reference plane A. In the software, the Plane 1 measurement command is obtained and renamed to PLNA. Insert a new coordinate system A1, select plane A, and align it to x-positive. Select the plane again, check X, and click Set Origin. Then, use the probe to collect 2 points on reference plane B. In the software, the Line 1 measurement command is obtained and renamed to LINB. Insert a new coordinate system A2, select line B, and rotate it around x-positive to y-positive. Select the line again, check Z, and click Set Origin. Finally, use the probe to collect a point on the third plane perpendicular to reference planes A and B. Obtain the Point 1 measurement command. And rename it to PNTC. Insert a new coordinate system. Select the point, check Y, click the origin point, set the y-axis to 0, and click OK. At this point, the coordinate system is established. The correct coordinate system origin and axis directions should be as shown in the diagram. In this course, through theoretical explanations and video demonstrations, we have thoroughly discussed the principles and steps of establishing a workpiece coordinate system using the 3-2-1 method. We have emphasized its key role in ensuring measurement accuracy and efficiency. We have learned how to restrict the 6 degrees of freedom of the part, and establish a stable workpiece coordinate system. Finally, please reflect on this lesson and complete the following exercises to consolidate the knowledge you learned today and deepen your understanding. This lesson ends here. See you in the next lesson.